Hi everyone. The topic for this week is single dimensional arrays. And just like with the topics from the previous 2 weeks, we start today with a quick example that illustrates the benefit of using this new tool. So the problem that we have to solve is we are required to read in 100 numbers, compute their average, and find out how many of those numbers are above the average. With what we know so far, if we were to use just that, we would have to use 100 different variables, which is really something that's not going to work really well for us. We won't be able to use a loop to accumulate the sum. And on top of all that, once we have computed the sum, we'll need to go through the entire set of values to figure out how many of those are above the average. So we need a new tool then, and that tool is called arrays. How do arrays work? We'll get into the low-level details in just a moment, but here is one good solution to that problem. In our main function, we declare an array called numbers. The square brackets here after the double data type indicate that numbers is supposed to be an array. An array is really just a list of values that have the same data type and that you store in memory using the same name, and that you can reference with the help of an index. So if numbers here is being declared as an array of doubles and it has a size of 100, that means it's going to have 100 different elements, all of which are of the same data type, double, and are referenced using the number's name. Okay, so in the solution here, we have a for loop that's going to go from 0 to whatever the number of elements is in the array, which in this case is 100, exclusive of the 100. And it will invite the user to enter those numbers one by one and then store the values in the array one by one. Please do note that the index of an array starts at 0, which is why we need to have that 0 here for the first index, for the first loop variable, and it goes all the way to whatever the length is, -1. So the last element will be numbers 99. As we read those numbers in, we also keep track of their sum. So we accumulate the sum, and we're going to use this in just a moment to calculate the average. On the second page, it's the second half of the solution. Once we have the sum, we know the count, we can calculate the average. We then set up a new for loop, which is going to go through the numbers one more time, going from 0 to 99 inclusive. I should say 0 to 100 exclusive of the 100. And then as we go through the entire list of values, we compare each one of those elements with the average. If the current element turns out to have a value higher than the average, then we increment the counter, keeping track of how many of the elements are higher than the average. This was just part of the problem that we were supposed to take care of. At the very end here, we print the average and we print the count of elements that happens to be higher than the average. So let me back up here for a second. Here is the declaration of the array. It's called numbers. It's all made up of double values. There's 100 of them, and then we use it twice. First, in the first for loop, we go through the entire array and we read in the values. As we do, we keep track of the sum of all those values. And then the second time, as we go through the array, we simply compare each element with the average, and we keep track of how many of those happen to be larger than our average. So this is a perfect example of a situation where a single dimensional array comes in really handy. Now, multi-dimensional arrays are going to be the topic for another video. We're going to concentrate on arrays that are linear in nature today, okay, that are single dimensional, have only one index. And this is just so you could visualize what the array looks like in memory. So a one-dimensional array is a data structure that stores a sequence of values, all of the same data type. And one more time, first element in the array is indexed as element 0, and the last one is whatever the length of the array is -1. So if the array is 10 elements, your final element here will be indexed as number 9. And that's the way it works in most other high-level languages. Alright. There's really 3 different steps in creating the array. We have to declare it. This is an example of a declaration. So we create an array called A. We haven't initialized it. We haven't done anything yet. We have only reserved memory for it. This part creates the array. Okay, so these first 2 steps are usually done in one step, really, just as you saw in the example. But this is the creation. This is where we set aside enough memory to store the array, and then finally we initialize all the values. One popular way of doing that is what you're seeing here. You're going to have a loop that's going to go through the entire list of elements of the array, and it will initialize each and every one of them. Alright, so that's the syntax. A quick note here, this kind of syntax is allowed in Java, but it's not preferred. Pretty much all programmers stick to the standard way of creating arrays, which is this one up here. So you have the data type followed by the square brackets and then some valid identifier for the name of the array. Okay, the creation part creates the array with the new keyword. So this is a keyword, and it assigns the reference of the newly created array to whatever the name of your array variable is. The reference is really just a pointer to the memory location where the array is stored. Okay, so your array name is kind of like a pointer. It points to that part of memory where the entire array is being stored. Alright, and we went over this a moment ago. First element is referenced as element number 0, and then if you've got 10 elements in your array, the last one will be number 9. I know I keep repeating myself, but this is important. We're going to run into this on quite a few occasions, and I'm sure this will at one point or another give us problems too. This is a very common pitfall for beginner level programmers. So here's how you declare and you create the array in one single step. We saw that in the example. 3 different arrays being created here. Nums is an array of 100 doubles. Primes is an array of 1000 integers. And names is an array of 24 strings. The array size, you use the length attribute of the array to request Java to give you the size of the array. So if we back up here, names and mylist was declared as an array of 10 integers, I believe. Let me double check. No, doubles. 10 doubles. So length will return 10. Names was an array of 24 strings, so length is going to give you 24. Yes. Alright. This is handled differently in different languages. In Java, once you have declared and created your array, all of its elements have also been initialized to either the value of 0 if they're integers or doubles, to the Unicode character 0 if this is an array of type character, or to false if this is an array of booleans. Okay, so you do have some initialization done by the system, but we normally don't want to count on that. Once we declare our arrays, we want to make sure that we also initialize them to some meaningful data that we intend to use. Alright, and we saw this earlier. The way we reference a particular element in the array, we use the array name, and then inside the square brackets we specify the index of the item we're trying to reference. This code down here is a quick example. What it does is it takes the first element in my list, adds it to the second element in my list, and the sum of those two gets assigned to the third element in my list. Okay, they're indexed 0, 1, and 2, but they're essentially the first, the second, and the third. Okay, it is also perfectly valid in Java to initialize an array once you declare it in the following way. This mylist here is an array of doubles. We don't specify the size of it. We just go ahead and directly initialize values to the elements. As you can see here, there's 4 different values. So Java is going to be able to figure out that mylist needs to be of size 4, and it will also go ahead and assign these 4 values to the 4 elements. Some programmers like this approach. This is completely analogous to the one down here. Neither one is more efficient than the other. It all depends, I guess, on the kind of problem you're solving. I usually go with the second one. It makes a little bit more sense to me, a little bit more intuitive, but it's entirely up to you to decide which one you use. If you know what values you'll be assigning, and it's not a really long list, then you can use this approach. If you do use the first approach, however, make sure that the assignment takes place on that same declaration line, and you don't do it in 2 separate statements, because that will cause an error. Okay, a nice little exercise for you. So if you want to try this out, this is really a great exercise. Just pause the video here and trace this little program, and then come back, unpause the video, and check and verify that you have the same result as I do. Well, my first question is, will there be any output based on this little piece of code? And what will the values of the elements of the array be after you execute the code? Okay, so pause the video, come back, and here's what the result should look like. Let me switch to JGrasp. Oops. So there is no output. We don't have any output statements. But if you have traced through the program, you should have, and you do that with the help of debugging. All the IDEs have that. You should have gotten the following results. So for your values array, it's made up of 5 elements. The first one at the very end should hold the value 11. Next one should have 1 stored in it. The next one 3. Next one 6, and next one 10. Alright, we could come back to this and do this in class, because it's really an excellent exercise in understanding how arrays work and how you traverse arrays. Alright, now back to our presentation. So in the next few steps, we're going to see some examples of how to initialize arrays, how to print them, sum all their values, find the largest values, shuffle them, and shift elements. First example is how you initialize an array with input values. You're going to use usually a for loop to run through the entire set of elements in your array and read in the values from the keyboard. Next slide shows how we can use the mathRandom function to initialize all of our elements to some random values. In this case, what is that? 0 through 99, I believe. On the next slide, we print the array. So the print statement is going to print each individual element of the array, and the for loop is going to make sure you go through the entire array. Summing the elements works in much the same way. We'll go through the entire array, only this time we add the value of each element to an accumulator. Do not forget to initialize the accumulator to a 0 before you do this. Find the largest element, something you may need to do on occasion. So the for loop again goes through the entire list of elements in the array, and as you do, you compare each and every one of those elements with your max value. Your max will be initialized to the very first element. So in English we're saying here, okay, let's just assume that our highest value is the one in the first element. Now we get inside the loop, we go through the rest of the elements. If we come across any elements that have higher values than max, then we simply update max. This guarantees you that after you're done with the loop, max is going to hold the highest or largest element of the loop, of the array. Random shuffling. Can help you shuffle elements if you need to do that, maybe in a computer game or something. What you do here is with the help of the for loop, again, you go through the entire index from 0 to length -1, and you pick a random index every time you get inside the loop, and you swap the current element with that random element. So when you're done with this loop, essentially what you would have done is you would have shuffled in a random manner your entire array. And as I said, this may come in handy if you want to test a sorting algorithm, or if you're programming a computer game, for example. Shifting elements, this little for loop here, well, initially we save or we retain the first element into a temporary variable, okay, because we're about to use this. And inside the for loop, we simply move every second element. We start with the first element, we copy the second into the first, then we go on to the next one, we copy the third into the second, then we copy the fourth into the third, and we keep doing this until we go through the entire array. Once we're done with the for loop, we can simply extract our first element from the temporary variable and then stick it into the very final element here. What this does for you is it simply shifts all the values one place to the left, and there are certain situations where this might come in handy. The for each loop, this is a structure or a statement that allows you to go through the entire array structure, always going left to right, so from beginning to end, and without changing the values of the array. So on occasion, this may be just an easier, simple way of traversing an entire array. You can see the syntax here. So you set up a for loop, and you simply provide the array here as the parameter, and then you describe what you need to happen. So updates to the for loop variable will not affect the array element. It's important to note, and if you need to traverse the array in a different order, then this isn't going to work for you. You really need just a simple regular for loop. Copying arrays works as well in Java. If assuming that list1 and list2 are two different arrays, you can do this. It's perfectly legal. Just keep in mind that what happens in memory really is just you're changing the reference of. So if you're doing list2 equals list1, you're setting up the list2 pointer to point to the same location where the list1 array is located. So your list1 and list2 arrays will be equal, but not because they are two different arrays, copies of each other, but rather because they're pointing to the same memory location where the data from list1 is stored. So keep that in mind. Array copy is a method that's that is available to you if you need to copy a chunk of elements from one array into another. You can use it. It takes 5 different arguments. The first one is the array you're copying from, the position where you start the copy, then the next one is the array destination array, then the destination position, and finally how many characters you're copying. So if you look at the example here, we got two different arrays, R1 and R2. In the snippet of code that follows the declaration, we copy only one character or one element, the one that's located at index 0 in array 1, into the one that's located at index 0 in array 2. So in English, what we're doing here is we're grabbing the 0 value from here and we're copying it into the first element down here. If you go ahead and print the values of array 2 at this point, they should look like this: 0, 10, 20, 30, 40, 50. Passing arrays to methods. This is also perfectly legal. You can do this in Java. You can pass along an entire array as an argument to a method. Keep in mind though, and I'll get to this in a second, that arrays are being passed by reference, which means this local variable here called array actually points to the array that is located outside. Okay, but let's take this slowly. So in this example, we have an array called list. It's made up of the following values: 3, 1, 2, 6, 4, 2. We've passed that entire array to the method called printArray. And printArray is going to take it, it's going to give it a different name. This points to the array outside, but locally it has a different name called array. And it prints all the elements one by one, separated by spaces. If you are calling a method to do something like this, you don't actually have to use a name for your array. Now this is really rare, but since this is legal as well, I decided to leave it in my presentation. In Java, when you call your method, you can just pass along an anonymous array. It doesn't have to have a name. The reason why that works is when you get inside the method here, you give it a name, right? So in here we could have passed along just int square brackets 3126442, okay, like so, and it would have still worked because we give it a name and we use it locally as array. The difference between passing by value and passing by reference, I try to explain that in the video on methods, but essentially all primitive data types are passed by value in Java. You don't really have the option of passing by reference, which means you're just creating a copy and you can never really affect the outside variable. Whereas with arrays, you're passing by reference, which means anything you do, if you change any elements of that local array variable, you are going to be changing the elements of the outside array. And here's a good example that illustrates this. So inside our main function, we have a simple integer variable, assign 1 to it, and an array called y, which is made up of 10 elements. We pass those, well, the array here is going to be initialized to zeros. If you recall this, in Java, by default, all the elements get zeros. So then we call the method called m, and we pass along the integer variable and the array. Now m is going to take those two. It will give them different names in here. The first one is going to be called number. It will get the value of 1001 assigned to it. The second one will be called numbers, and its very first element will get the value 5555 assigned to it. Now when this method m finishes and you come back to main and you print the values of x and y, what you will discover is that x hasn't changed, so this will print a 1. Whereas with the second one, the first element of y would have changed, and this is going to print 5555. So x is being passed by value, y is being passed by reference. You can return an array as the result of a method. So your method could be a value returning method with an entire array being returned. Here's the syntax for that. Well, in this example, we got public static int square brackets, which means when this thing gets done, we will be returning an array of integers. It takes an array of integers as well as the parameter. In here, the for loop is going to reverse that array, and then when it's done, it will return the result back to the calling function. Searching array, the final main topic, subtopic of this topic rather. There's quite a few interesting different algorithms for searching arrays. We're going to look at only two of them today: linear search and binary search. As you will discover, one of the main benefits of using arrays is that they can be searched. The other really big benefit of using arrays is that they can be sorted, but that won't be covered in the video today. We're only looking at searches. The first search algorithm is called the linear search, and the way that it works is you start from the beginning and you sequentially go through all the elements until you either reach the end of the array and you don't find what you're looking for, or you find a match for the key. The key is the value you're looking for, and then you return that as the result. How does that work in code? You're going to set up your for loop to start at the beginning and go all the way to length -1. If you ever come across an element that matches your key, you stop the search. You have found what you were looking for, and you return the index. There's different implementations of the linear search, but this is probably the most popular one. And if you survive the for loop and you go through the entire for loop, and then you come to the next statement down here, you know that you haven't found the key, so you return a -1, which you're going to use as an indication of an unsuccessful search. So you were looking for a key and it just wasn't in the array. The binary search is a little bit more complicated. It's a lot more faster. It does require, however, that your array is pre-sorted. Okay, and even if you have to sort your array and then search it, it may very well still be way faster than the linear search. Okay, and for this to work, generally you do not want to have repeating values in your array. There may still be a version where you could make some use of a search for an array that has repeating values, but I can't really think of a situation where that might actually be of any use. So we're assuming here that our array is going to be made up of unique values. So how does it work? We pick the element in the middle. If your array is made up of an odd number of elements, that's an easy one. Let's say if you've got 9 of them, you got 4 on one side, 4 on the other, and then you get the element in the middle. If you, however, your array is made up of an even number of elements, then you simply decide which one is to be considered the one in the middle. Okay, like let's say your array is made up of 8 elements. You can choose element number 4 or element number 5 to be the one in the middle. It's entirely up to you. The search is going to work just the same. Once you have selected the element in the middle, you compare the value. If that's equal to the key, you have found what you were looking for. You're done. If it's less than the key, if the key is less than the middle element, then you only need to search the first half of the array. That's because the array has been pre-sorted for you, and you know that if that key exists, it's got to be in the first half. Likewise, if you determine that the key is greater than the element that's in the middle, then you know if it's there, it's got to be in the right side, because that's where the greater elements are. Visually, here's how this is going to work. Let's say we got this array here with values 1 through 9. We're looking for the number 8. Okay, the element in the middle is this one right here. We pick this one. It has a value of 4. That happens to be less than 8. We know we can isolate this entire left part and disregard it and only look into the right part. So we do that. Again, we cut the data size in half. We look at the element in the middle, which in this case happens to hold a value of 7. That's still less than 8, which means we can disregard the left half. We go on into the third iteration, cut the data size in half, look at the element in the middle. Well, this time we do come across an 8. We have found what we were looking for. We are done, and we're going to return what index? It's index number 7, is it? Yeah, index 7. That's where we have found the key. And on our last slide here in the presentation, you can see the actual implementation. Just like with the linear search, there's different implementations of these. Some more efficient, some easier to read, and what you're seeing right now is probably the most common, most popular implementation of the binary search. So there's a couple of pointers there that are being used, and we got a while loop that does all the calculations. At the very end, if you survive that while loop, that means you haven't found what you were looking for. You will return a -1. Or if you come across the key, then you're going to hit the return statement, and that's what you will return back to the calling function. Alright, this is where we finish our new topic, single dimensional arrays. Thank you very much for watching.